For IPv4, any IPv4 address starting from 224 to 239 is a multicast address. In IPv6, it's anything starting with FF. It doesn't have to be 00, but FF, first 8 bits, 4 and 4. Okay, that's a IPv4 and IPv6 multicast addresses. Ethernet also has multicast addresses. As for destination MAC address, the multicast address for IPv4 typically starts with these first 48 bits. I'm sorry, excuse me, first 24 bits. I'm choking here a little bit. First, so this would be what we think of as the organizationally unique identifier, which is actually the vendor portion. But in this case, this says this is reserved for a multicast address for Ethernet. For IPv6, we're going to see 3333 as the first. Actually, doesn't even it. You can see it's 4 4, so that's 8 16 bits, and we'll see that it actually does add on another 4 bits here, or another 8 bits. But it starts with 3333. Okay, so how's this multicast used? Well, when we use multicast in IPv4 or IPv6, if IP is using a multicast address, okay, it's going to be the IPv4 or IPv6 packet is going to be encapsulated in Ethernet. Okay, there is actually a corresponding, a relationship most of the time between this this multicast IP address and this multicast MAC address. Now, how is this? Why is it in this? Does Ethernet care? Why don't we just send everything out as maybe a broadcast for Ethernet? Well, this is important because, ignore that down there. Ethernet switches may direct multicast traffic out only to those devices that are members of that group. Don't worry about that. Actually, switches by default don't do that. They have to be configured to do this, and they have to run a certain protocol to do this. Usually, Ethernet switches, if they see a destination MAC address that's a multicast, will send it out all ports. And I haven't shown you any examples or anything yet. We will get there. Take it a little slow. But here's one of the big benefits is for the Ethernet NIC card. The Ethernet NIC card can make a determination whether or not this Ethernet frame is for it or not. Okay. It will accept frames based on the destination MAC address. Typically, what we think of is, hey, if it matches my MAC address, my unique MAC address, yes, I got to accept that frame. Hey, in IPv4, or not just IPv4, anything that's non-IPv6 in the data, because other protocols can use a broadcast. But if it's 48 1 bits, hey, I've got to accept it. This is for everybody. But your NIC card also accepts specific Ethernet multicast addresses. Okay. So here is my Ethernet NIC card at home. It's going to accept any Ethernet frames going for this MAC address. You can see it right there. I did ifconfig. Okay, you can do on Windows, you can do ipconfig /all, and it will show you your Ethernet MAC address. That should be unique to your Ethernet NIC card and only your Ethernet NIC card. And your Ethernet NIC card will accept anything with that destination MAC address. Okay, that's cool. I have all these other, so it's a unicast. I think this is a unicast address meant for one device, in this case, my NIC card. These are all unicast addresses here in this red color. these are my IPv6 unicast addresses, and this blue, this is my IPv4 unicast address. By the way, this net mask, subnet mask, is shown in hexadecimal. So just so you know, this is all 1 bits here, 4141. So this is 255, then 8 1 bits, 255, FF. Another FF, 8 1 bits, 255, FF, another 8 1 bits, 255, and then 0080 bits, 0, 255, 255, 255, 0. Because you know hex. All right. Now, that's showing my unicast, at least my unicast MAC address, my unicast IP addresses. Can I look at what it allows to come in for multicast? You can. No, but people usually don't look at this. But we can use this command right here, netstat-g. Now, netstat is one of those commands that, wow, can be used for many things. I'm going to open up a new window here just to show you. Here, I'm not on IPv6 here. I'm on IPv4. This is your network status. And just to show netstat all by itself, it's giving me all kinds of information about my connections and everything. It's still going, okay? So I use this for all kinds of stuff when I'm looking at things, but with all kinds of, let me get rid of that there. Okay, you can terminate my other window. This command here says netstat-g, show me my multicast groups that I'm a member of. Now, what is this pipe symbol grep EN0? Don't worry about that, but what I did is I didn't want to see it for all these other interfaces that's on my computer. Let's see if I've got it without that now. But I didn't want to show it with well, I do have it. If I do it without that, it'll show me all kinds of stuff, more than I care about. No, I don't have it. Okay. It'll show me all my interfaces. This, I just want to show you on the interface that I'm connected to the network. In green, and I'm at home here, and I'm running IPv4 and IPv6. These in green these are all the Ethernet multicast MAC addresses that my Ethernet NIC card says anything with this destination MAC address, I'm accepting. Multicast. I'm accepting. Okay. Now, I don't expect you to know what any of this is. We haven't talked about it. But look at a couple of things. Do you see where it says 1:0:F5E? That is for IPv4. I have another one here, IPv4, only two. And these are two common ones you'll find on your computer, any computer for IPv4. This one here is a multicast address. I'm going to kind of not get into this too much. But this is actually a multicast address. I'm going to bring up my E2Go without messing me up too much here. No, it's not playing well. Okay. This one here is for a 224.001 address. This is all IPv4 addresses. In case it's just when you're an IPv4 enabled device, which all of our devices are, of course, it's going to accept anything for the multicast group. Hey, all IPv4 devices. Okay. This one down here you'll see a lot. That does not stand for Facebook. This is for multicast DNS. I won't get into multicast DNS, although I think it is a very interesting topic and something we should touch on a little bit in our networking classes. Multicast DNS is a way that, I'm not going to get into the weeds here, but this is how for example, at home, in your little local area network, at home or at school, but let's just say at home. This is how your wireless printer, for example, or wired printer can announce itself. Say, hey, I'm this printer here, and this is my IP address. And all the devices on the network can be configured, the operating systems are configured. Hey, I see that you're announcing yourself to everybody using this address. Hey, you're a wire you're in this case a wireless printer. You're and in the data you're giving me your IP address and your printer name. So then my operating system says, oh, okay, if I want to use, if I'm in Microsoft Word and I want to send something to printer, I go to print, hey, and there's that printer, and I can send it to that printer. So it's how we can actually do things like have printers with dynamic IP addresses. Okay? They don't have to have a static address. So anyway, that's why you see this FB. Okay. You notice all these other ones, 33, 33, 33, 33, 33, 30, all these 33, 33s, some with zeros, some with FF. Those are IPv6. So if you're not running IPv6, you are running IPv6. You'll see some of these. Like you will see this one here. See that FB? Again, multicast DNS. You'll also see this one here. Okay, we'll talk about that in a moment. And well, that's just for all like this one here is for all IPv4 devices. This is for all IPv6 devices. Okay, so there's my Ethernet. So my NIC card is going to accept any Ethernet frames for that destination MAC address. Okay, great, Rick, but where do we use multicast? Still don't get it. Okay. So again, just to bring this home first, this is my Ethernet MAC address. My NIC card says I'll accept anything for this. I'll accept anything that's a broadcast. And it's not going to be IPv6, by the way. IPv6 will never use this. Okay. And I'm also going to accept anything for any of these MAC addresses. So this is everything my NIC card will accept. Destination MAC addresses that match any of these. Okay. All right. Now, we will see later here that you also netstat-g, I didn't show you the whole thing yet, but here it is. Most of these MAC addresses, all these MAC addresses actually, will get mapped to an IPv4 address. So remember I mentioned that a IPv4 packet, so I'm going to go in between some things here. An IPv4 packet, this destination multicast IP address will be mapped to a destination multicast MAC address. Okay. So when we send out something, if you wanted to send something or an application wanted to send something out to all IPv4 devices, this would be the destination IP address, which would then get mapped to the destination MAC address. I mentioned multicast DNS. So this is something that goes out to, which is for multicast DNS. Anybody listening to multicast DNS gets mapped. That destination IP address gets mapped to this destination MAC address. And here's all the IPv6 stuff. So there is a mapping between Ethernet IP multicast and destination MAC address multicast. All right, let me get past all this. Let's get into multicast. Let's talk about this. And then we're going to see how it starts getting used. But I just want to get you thinking IP multicast, Ethernet multicast. There's a connection there. Okay. So multicast. In IPv6, we have what's known as well-known, transient, and solicit node. So we're going to focus on well-known right now. The transient, we're not going to worry about. The solicited node, yeah, we're going to talk about that. And look, wow, that is an ugly address. Okay. But this is what we use for things similar to an ARP request. We'll get there. Okay, so I already talked about the relationship. Let's talk about IPv4 and IPv6, first of all, the source addresses are always unicast. They'll never be broadcast or multicast. Got to come from one device. Destination addresses can be unicast, multicast, or anycast. An anycast is just another unicast address. I talked a little bit about that in CIS 81 this week. We talked a little bit about anycast. In IPv4, of course, we can also use a destination address that's a broadcast. So we saw that a multicast is when we want to send a packet to multiple devices at the one packet for everybody. Okay, how does one packet get to everybody? It leaves a device as a single packet, but the Ethernet switches will duplicate it. So when it's sent in an Ethernet frame, the Ethernet switch will go just like, think of like a broadcast. Ethernet switch gets a single Ethernet frame that the destination MAC address is a broadcast, and it floods it out all ports, right? Duplicates it in all those ports. Same thing with a multicast. It actually duplicates that frame, okay, the Ethernet frame. That's a destination MAC address is a multicast, treats it like a broadcast by default. It will flood it out, duplicate it out all ports, except the incoming port. Now, why are we showing it only going to these devices? Because these are the only devices that will accept it. In a broadcast, everybody would accept it. The Ethernet NIC cards, they'd all accept it. With a multicast, only certain devices are going to accept it because it's only for certain devices. In a broadcast, it's for everybody. Okay. Let's get. All right. So this is the range. Actually, a multicast address is anything starting with FF, which is actually 81 bits. That's what that /8 means. The first 8 bits are FF, all 1 bits. Okay. There's some different flags. We're not going to worry about it, except that we're going to be seeing a 0, meaning it's predefined. Okay, so we're going to be using FF0. There is what they call transient or assigned. These are usually by applications. I'm just going to show you an example here. We're going to be using FF0 for everything, but FF1 would be something that an application has been assigned its own multicast group. We're not going to worry about that. Okay, let's get past that. There is a scope. Okay, now here's the partial list of scope. There's actually for interface only. That's for testing purposes. We're not going to worry about that. This is the one we're going to be using. FF02, link local scope. That's what we're going to be using, and by far the most common. Matter of fact, when we looked at my multicast stuff here, notice all these FFs. This is interface. Those are just that. Don't worry about that. Multicast, permanent, 2. Link local scope, link local scope, link local scope. All of these are link local scopes. I have some that's just for testing. If I want to, test myself, that are my IPv6. Everything else is link local scope. I'm going to look at those link local scopes. Link local scopes, by the way, means not past the router. That doesn't mean link local address. Talk about the, we'll clear that up. Make sure there's no confusion between a multicast address with link local scope and a link local address. What? Yeah, we'll clear it up. Okay, but we can also send multicast to our site, meaning we can actually forward multicasts beyond the router. We can even forward it within, even if we, possibly, amongst our entire organization. There is global, but that has to do with something else. All right. So what we're going to be using is FF0. Two, again, link local scope means this is just within our Ethernet LAN, not past that router. Okay. But there, if I wanted to send something to all IPv6 devices, but not past the router, like hey, everybody in my network, hey, which one of you, let's see, actually, this is all IPv6 routers. So this is a special group. We'll talk about that too there. This is a special address for all IPv6 routers. So if my device said, I need to find my local router. Hey, I'll send a packet to this IPv6 address. Hey, FF02:2. We'll talk about this here in a moment. This is for anybody who's an IPv6 router. I need some information from you. Now, every device on my network is going to get this, perhaps, but only the IPv6 router is going to accept this. We'll see that in a moment. But it's not going to go past the router. If I was trying to send something to all IPv6 routers in my entire network, then I would set it to a 5. Site local scope. That means, the router will forward these. Okay. We're not gonna get into that though. Okay, we're gonna keep everything very simple, which is the majority of the 99% of what we do in IPv6, multicast with link local scope. Just so there's hopefully no confusion here, but if there is, let's clarify it. Okay. We talked about link local addresses on Tuesday. A link local address is a unicast address. Okay. My device has a link local address. So let's take a look at that. Okay. Let's remind ourselves what link local addresses are. Nice and big. My device has a link local address. That's an address that's only good on its link. Okay. It's, that's an address, and if I can send package, we'll see when it uses this link local address. Let me show you another example of a link local address. Bring this up because I'm not on an IPv6 network here. One second here. Oh no, what I oh no, I didn't just move that, did I? All right, I think I got it here. Oh, shoot. Sorry about this. Moving things around. I hope I didn't delete my folder. It's probably my trash, but give me 1 second here. All right, that's okay. Find it at the break. Okay, what I was trying to show you is I also have the link. I also will use the link local address of the router as my default gateway. All right, sorry about that. Okay, So link local addresses. Can I use this as a source address? Certainly. Can I use it as a destination address? Certainly. Uh, it's a, it's one to one. Is it routable off the link? No. Link local addresses, okay? Nobody can, only those devices on my network can reach me at that address. I can only reach my router's link local address if it's on my network, not past the router. Okay. Multicast though, can I use it as a source address? No, this is only for destination addresses. Can it go beyond the router? Yes, as long as this scope flag is other than a 1 or a 2. Then it can go beyond the router. But we're not going to worry about that. Okay. So this is how both a link local address and a multicast address gets used. So we will see here, we're going to be talking about this on Tuesday. Very cool on Tuesday. We're going to get into dynamic addressing. That's when we're going to start bringing all of this together. Okay. When your computer connects to the network or IPv6, remember with D8 and IPv4, it's configured usually by default to obtain its IP addressing automatically. It's IPv4 addressing automatically. It uses DHCP, Dynamic Host Configuration Protocol. Okay? And it knows that it has to get its addressing from a DHCP server. IPv6, no. IPv6 says maybe there's a DHCPv6 server, but you tell me. Who's you? Who's going to tell me? The router. So when your computer attaches to the network, plug it in, join the Wi-Fi. What it does is it sends out an IPv6 packet that has an ICMPv6. We'll talk about this later, okay? Tuesday. Router solicitation message. So here's the packet. This is what the packet looks like. The source IPv6 address is your link local address. Yes, the link local. Remember how it got that link local address? Your device gave it to it itself. It says, I'm going to use FE80 and then a random 64 bits. This is now me. This is now me. So I've got an IPv6 address. I can talk to anybody on my network here. And I'm going to. I'm going to use my address and I'm going to send a packet to a group of devices, a multicast group. I'm looking for somebody that belongs to this group. The group I'm looking for is all IPv6 routers. Are you an IPv6 router? What do I mean by all? Because, hey, could you have more than one router on your network? Certainly. Okay. At home, typically not. So this is going to the destination IPv6 address is multicast. It's FF, that's the multicast, 02, link local scope. That tells the router, do not forward this beyond you. I'm only interested, this is only for any devices. What devices? This :2 means all IPv6 routers. So I'm only looking for any IPv6 router that's on my link, not beyond you. So this message potentially can go out to everybody. Okay, we'll talk about that. Yeah. So this is a link local address, source address, which is unicast. This is a multicast destination address with link local scope. Does that make sense? Okay. Good. All right. Now, what comes back from the router, by the way? The router actually sends from its address, it sends it from its link local address. It says, Rick configured me with FE80:1, so it'd be really easy to recognize me when you're on a computer. looking at your default gateway. So I'm going to send this from my link local address. And by the way, when you receive this WinPC, I'm sending you this from my source IPv6 address, my link local address. Use that as your default gateway. Now, who am I sending this to? I'm not just going to send it to you. Could I? So the decision was made. You're only this PC is asking for it. So the destination address could go back to this specific link local address. It could have, but that's not how they designed the protocol. They designed the protocol, said if you're asking, you know, I might as well tell everybody. It's kind of like, you know, if somebody in class asked me, hey, Rick, you know, when did you say that? When is our midterm exam due? Well, instead of me just telling you, let me tell the entire class. By the way, everybody, maybe this is new information, maybe this is a reminder, but the midterm exam will be due next Wednesday at midnight. So that's what the router advertisement message does. It says, you know, instead of me just telling you, let me tell everybody on our network. So I'm going to send it to a multicast address, FF multicast 02, link local, meaning this is only for anybody on my network. Meaning if there's another router on our network, don't forward this. This is just for everybody on our link, our network. Now notice the :1. That's different than the :2. :1 is for all IPv6 devices. Anybody who's an IPv6 device, you need to accept this. Sounds a lot like a broadcast to me. It is. Okay? Because if we had a device that was not enabled for IPv6, for some, nowadays that's just not the case. Okay? If we had a device that was not enabled for IPv6, then it would not accept this. Now, let's back up a little bit here. And remember, I did that netstat-g. Let's go back to this here. I'm trying to be real careful not to accidentally close this window. All right. I did netstat-g on my home computer. See what multicast groups it belongs to. Can you see what multicast group? Do you see this? Does it belong to the FF02:1 multicast group? Now, a lot of FF02:1s, but those are something else because they got other stuff. Right there. See this here? My NIC card says, yes, I belong to that group. Yeah, Pamela.
Rick, so how did you know that was the one to focus on when all those other ones say FF02, like semicolon twice one?
Yeah, because these here, this is, so that's a good question. This is FF02, all zeros and a 1. This here has more zeros in it because there's nothing in between the 2 and the 1. Look at this one here. So if we go backwards, this is 16 bits, 16 bits. This is 32 bits right there. Another 16 bits, that's 48 bits. Here, this is just this, there's just a 2, let's see, I'm sorry, down here. This one here, there's just a 1 right here. There's nothing after it. So this 1 is at the end. Let me do it this way. Okay, so if I was to write these 2 out, so let's do that. Let me take this one. And let me take this one. Let me show you the difference. let's write it out completely. This is very good question. So what this, remember, so what our addresses are is this. So this is actually FF02. Now what I'm going to do is just copy this. Okay. And let's put the zeros in front of it. Okay. Now that's not the whole address, right? There's 8 hextets. So there's actually another group there. Another group there. Another group there. So we got 1, 2, 3, 4, 5, 6. Need one more. So that's actually this address here. This is at the end. Okay, does that make sense so far?
Yes, thank you.
Let's do this now. Okay, let's put the zeros in front of this. Okay, and I'm going to cheat here. So this is this address here. So what I was looking for was just this. This is the multicast. And we're going to look at it more closely here in a moment. But really what we're focusing on is the multicast is FF02, and this is the first 64 bits of a multicast.
Thank you.
You're welcome. And I'm going to get to this next, so that's a good question. This says I belong. This is the group number. This says all IPv6 devices. So this is all IPv6 devices. We saw the other one, by the way, that we sent a message to all IPv6 routers. We're going to see this coming up here in just a moment. This one here, the all IPv6 routers. Take a look at that, because that's really easy to copy and paste. This usually gets me into trouble, though. This is where I make all IPv6 routers. Put a 2 here. Put a 2 here. Okay. This one here is only, we're going to do this here in a moment, but only routers will be enabled for this, except this. So yeah, let's talk about this some more. Okay. So these are what are known as well-known multicast addresses. Well-known. Well-known. Okay. What are well-known multicast addresses? Okay, well, we just saw one. FF02:1. So that's actually FF02, all zeros. Okay, and I did a little differently here. Oops, that's not a little differently there. This is a group defined for just, this is a group defined just for, well, all IPv6 devices. If you're an IPv6 device, you belong to this group. You belong to that group. Okay. So that's a group my computer belongs to. And your computer too. And your phone. Now, you notice, so that means link local scope. Here's one for all IPv6 device routers. You'll notice that is not, my computer is not FF02, all zeros and a 2. That's for routers. You're not going to see, you see FF02, but you're not going to see :2. You're not going to see :2 here. No, this is a :2. Oh, wait a minute, there's more to it. That 2 is not at the end. That this is what the routers look. That too would be at the very end. So my device is not an IPv6 router. Okay. This, see, even that two's at the end, but there's a bunch of other stuff there. We'll see with a router in a moment. Okay. This is, so in routing protocols, when one router has a message to send to another router, I want to send you some OSPF routing protocol information. We're going to talk about this in CIS 82 next semester. We won't get into IPv6 with it, but it's the same thing. It says, hey, any OSPF routers out there? If we're sending that over IPv6, it would send it to this group. I mean, if another router's on that same shared network, if you and I are neighbors, we have a cable between us, both running this same routing protocol, yeah, you'll be listening to that and you'll accept my messages. If somebody else, another device, it's just a regular computer, they're not running OSPF routing protocol, they're not a router that is doing what we're doing, they'll ignore this. So these are all known as well-known multicast groups. And by the way, these exist in IPv4 as well. Okay, the differences in IPv4, they exist with 224. Remember this? This is my computer saying I belong, make that nice and big. This is my computer saying I belong to the all IPv6 multicast group, any IPv6 device. You know, my computer also belongs to the all IPv4 devices multicast group. Notice it's really the same. There's a one. Just that this is 224, and this is, make sure I get the right one here, FF02. This means IPv6, this means IPv4. This is the all where are you? The all IPv6 devices. This is the all IPv4 devices. Okay. So we do belong to these multicast groups in IPv4 also, at least the all devices. We just utilize this much more in IPv6. Why? We'll see a little bit of at least a perceived, back when this was designed, a perceived and a benefit, perceived benefit, but perhaps it actually made things more confusing for people wanting to transition to IPv6 than what was necessary. There, you know, people design these things. Okay. We're not going to worry about scope. Okay, let's do this. Let's take a break, and I'm going to bring up Packet Tracer. Okay, and then we will take a look at as much as I can in Packet Tracer. But don't worry, because Tuesday we're going to look at this using real network stuff, and we're going to bring some stuff home. Trust me. Okay, we'll get there. So this is just kind of an introduction into multicast today. But we're going to be using it throughout. You go, oh, I see how that's used. I see how, now I'm beginning to see how this gets mapped from not that one, no, we don't want that. From a destination multicast IP address to a destination multicast MAC address. And we'll also see the benefits of it. So we're just going to ease our way into it today. And then Tuesday, when we start looking at how devices automatically get their IP addresses, router advertisement messages, all this good stuff, and also how ARP is used in IPv6, then you're going to see, oh, okay, no broadcast, we're using multicast. Now I'm seeing how multicast works a little bit. Okay. You're getting, this is, you know, I know somebody asked me in 81, how, you know, if I'm 75% of the way there understanding this, am I okay? You're more than okay. This is a first exposure to this stuff. like any of this stuff, it makes more sense later, even in this class. But also, the more you work with anything, and anytime you see it in a different context, a different class, you're in on your computer, you're doing something, then it starts to say, yes, I'm seeing it again. I'm seeing it applied differently, talked about differently. It'll start making more sense. So don't worry about anytime you first learn something, you don't become an expert on it or memorize these things instantly. At least I don't. Maybe you do, but definitely I don't. All right, let's take a 5 minute break. When I come back, remind me, I need to answer a couple of questions from somebody that emailed me that had some really good questions. All right, see you is 5 minutes okay?
Recording stopped.
And
Would 8 minutes be too much? Oh, that's
no, 8 minutes is actually really good.
fine. Okay, thanks.
Yeah, that's my go-to. Just bring up remind me to record. There we go. Okay, John sent me a good message. I'm trying to copy it. That, why, I can't believe this. The chat in Zoom does not let you copy a message. You've got to be kidding. All right, let me just use this here. Let me start the recording.
Recording in progress.
Okay, John just let me know about let me put this in there. You can use, Linux users can use the IP address command. And he says, the ifconfig program is part of the net tools package. You can install it with a sudo space. So let me type that in. So sudo apt install net tools command. Spell install. There we go. Net tools. So again, Linux users can use the IP space address. The ifconfig program is part of the net tools package. You can install it with this. So, thank you, John. Google search, install ifconfig on Linux. Thank you. Anything Linux, I asked John. Okay, I need to get to something here in a moment. I just want to show you one other thing here. I want to answer a couple of questions first. But before I do that, I'm on my computer, right? This is live on my computer. I'm on an IPv4 only network. But so notice I do have a link local address, IPv6. So if I do my netstat-g, notice, okay, here's my IPv4. I'm a member of the all IPv4 unicast group. Okay, there's the IPv4, and this maps, we'll see later, to a MAC address. This is the multicast DNS for IPv4, but I'm also, because I am enabled for IPv6, I have a link local address. Okay, I belong to the all IPv6 multicast group, all IPv6 devices. Okay. And this would be the corresponding MAC address. Okay, we'll see how that's used. We don't get there today, we'll definitely get there on Tuesday. Before I do go any further, let me mention answer a couple of questions. I have a couple of very good questions from somebody in email. I want to make sure I get to those. This is going back to global unicast addresses and just overall IPv4, IPv6. One question was very good. Is there a conversion protocol that will translate IP version 4 to IP version 6? I'm thinking about something a router could use so IPv4 only network can communicate with IPv6 network and vice versa. What a great question. And yes and no. I mean, so IPv6, they were looking at different ways to transition from IPv4 to IPv6. And there were some methods in place to try and do this transition. They were full of problems. Some worked, some didn't, delays. Basically, you can fit an IPv4 address in an IPv6 address. You could, but it's just one of those things that everybody has different ideas on how to do something. So although there are some ways to translate IPv4 and IPv6 and vice versa, they never really took hold. How does the host change the packet size if using IPv6, if it reads a packet too big message? we'll talk about that, but basically, we'll, we'll talk more about MTUs in general, maximum transmission unit. But typically, your device determines that. Whoever is sending the packet, and what it uses is it looks at what your connection, your layer 2 connection is, which is typically Ethernet. Ethernet has 1,518 bytes, which means the data is about 1,500 bytes. So it adjusts. Said, okay, if the IP header, IPv4, IPv6 is so many bytes, now the IPv6 header will be larger by 20 bytes. So it will adjust the data that it puts inside. So we'll see this a little later, but the data that goes inside the IP packet will be adjusted to the size of what what's allowed for data for an Ethernet frame. Utilizing IPv6 with so many possible addresses worldwide and no network translation, is there potential for conversion problems? This is a very good question, meaning, are we gonna have too many networks out there? So the answer is shouldn't be, because what we try and do is summarize networks. So, for example, let me see if I can show you my address at home or something. I got so many windows open now. And we talk about this in CIS 82 and a little bit in CIS 83 as well. But a router's routing table is usually just going to be internet routing tables are summaries of different networks. Trying to see if I can find a quick example here. Let me just kind of do this real quick here. So the question again is really, so many IPv6 addresses and networks, is that going to cause a problem? And here's the reason why. So here at, let's say at Cabrillo, we have the 2001, what is that? I'm just going to make something up here. I can't remember what it is offhand. 80F, actually, I'll just use this here. Sorry, I'm having a little freezing issue here. There we go. Here's my address at home. Yeah, but this is my network address. Does the internet see me as that? No. The Comcast sees me as that. The internet probably sees Comcast. So to get to Comcast, all other outside of Comcast, they are only saying, hey, anything with 2601.646, I'm going to send to the Comcast autonomous system. However, I can get to Comcast. So they don't have to carry all these separate networks for Comcast. They just say everything Comcast, this is like level 3 and Facebook and Netflix and whoever's out there, okay? WinStar, all these ISPs, they just say, hey, we just have one address for everything Comcast. We get it. So when they see a packet like this, they don't see Rick's network. They see just this in there. So they have this covering everything Comcast. Send it to Comcast. Then Comcast says, oh, let me look out 64 bits instead of just 32. Now I've got it. Oh yeah, I got to get this to Rick's house. So those are very good questions. Will there be need to upgrade bandwidth, larger? So I think I answered all that. So you know, the other thing too, is we talked about this in class, content delivery networks. Content is getting closer to where we are. So we're not routing as much as we needed to years ago. Because now within the autonomous system, yes, but we're getting things closer and closer to where we are. All right, so let me talk a little bit more about IPv6 multicast with packet tracer. Show you how this works. Okay, so here I have my router. Okay. And right now, if I do show IPv6 interface brief, okay, on Git, let's pay attention. Let's focus, not pay attention. Let's focus on gigabit 00. Move this over here. There we go. Gigabit 00. Okay, so I have a link local address and a global unicast address. Okay, now if I do this command here, I can see what multicast groups is part of this interface. If I do show IPv6 interface, gigabit 000, oops, 00. There we go. Okay, so what's this telling me about IPv6 information on this interface? Okay, it's saying it's up, that's good. I'm IPv6 enabled, yes. This is my link local address, yes, because I configured that. This is my global unicast address, configured that. And I'm on this subnet, on that global unicast address. Great. Now notice this. It says these are my multicast groups. FF02:1. That's the all IPv6 devices. Okay. Now we're going to talk about this one. We won't get to it today. We'll talk about it on Tuesday and Thursday. This is known as a solicited node multicast. Don't worry about that right now. Okay. It actually is related to our unicast. So don't worry about that. But notice the only well-known group I'm a member of is all IPv6 devices. What group do you notice that I'm not a member of? I'm not a member of what group? All IPv6. I am devices, but I want to be more special than that. All IPv6 routers. I'm not a member of that group, not yet, because I got to do something. Okay, so over here on WinPC, okay, or yeah, WinPC, I say kinda, because it doesn't let me do, I tried to do netstat-t, it didn't let me do it. I do ipconfig, okay, notice, okay, I have a link local IPv6 device address. I've been configured, make sure configured, IPv6, hey, automatic, but I'm not getting anything from the router. Hey, shouldn't it be giving me a prefix, router advertisement with a prefix so I can create my own address? We kind of introduced that, we'll see it in a moment. But I'm getting nothing, I'm doing nothing. All I have is this link local address, that's it. Okay, no IPv6 address. Let's go back to our router. I'm not acting as an IPv6 router yet. I have to issue this one command. Okay, and I'm going to do this here. Debug IPv6 ND. Okay, you're going to see something start here in a moment. This is debug means I want to show me what's happening. When I do IPv6, show me anything to do with called neighbor discovery. Start introducing this on Tuesday. This is going to send out something called a router advertisement. After I do this, I got to configure the router, say you are IPv6 unicast routing. This command makes this router an IPv6 router. Now, as soon as I hit enter here, this router is going to say, oh, I'm an IPv6 router. Great, I'm gonna send out router advertisement messages. Let everybody know I'm the router, and this is everything you need to know about your network. Let's do it. Wow, notice as soon as I hit that, I got a bunch of stuff. Let me make sure it's everything I need here. Yeah, we do undebug all. Okay, turn that off. My router, as soon as this is so cool. As soon as I gave this command, my router starts letting everybody know on this interface and this interface. Let's just focus on this interface. So, what it sent out, gigs, so we're looking at this interface here, gig 000, gig 00. It's sending what's known as a router advertisement message. It's sending it from its link local address. And it's sending it to a multicast address, all IPv6 devices. So it's telling all IPv6 devices on this network, this is a router advertisement. I'm sending it, if you're enabled for IPv6, listen to this message. First of all, this is my source IPv6 address. Use that as your default gateway. I'm also letting you know, this is our network prefix. This is the IPv6 network you belong to. Okay, we're gonna see how this is gonna use this. There's a little flag here called the A flag. This isn't LA, like LA Dodgers, okay? No, we wouldn't do that. We'd have like SF for San Francisco Giants. Okay, A, that means the auto configuration flag. That's letting the device know, hey, you should create your own address, your own interface, host portion. Use this prefix and create your own 64-bit host portion, interface ID. Okay, by the way, there's that MTU. It's telling the device, by the way, our size of our packets are 1500 bytes. So adjust accordingly with header, TCP header, IPv6 header, TCP header, UDP header, and then whatever data goes inside. It's gonna be a total of 1500 bytes. Okay, so we sent that out. Let's see what this PC did with it now. Remember before, it didn't have that information, so it just gave itself its own link local address. Let's redo this. IP config. Wow, look at this. It grabbed that network prefix. Now I know what network I'm on, and I'll create my own interface ID. And before we get to the interface ID, you sent this from your source IPv6 address, which was a link local address. I'm going to use you as my default gateway. And I know you're on my link. I know you are because this is your link local address, which means you could have only sent this to me as a source IPv6 address if it was on that link with me. You can't send a source IPv6 link local address from a different interface, although it can use the same address for both. But this is telling me, hey, I can reach you via this link local address. I can reach you directly as my default router, my default gateway, my local post office. I don't have to go through another router to get there because I can't do that. You've got to be local to me. Now this here, how did it create its own interface ID? Okay, we can see that right here. Here's its IPv6 address once again. Here's the interface portion. Here's its MAC address. So remember what it did? 24 bits there, 24 bits. FFFE in the middle. So it's using EUI64, not a random value. And then it says, let me grab the other 24 bits, but let me change that second hexadecimal digit, flip the 7th bit, so it goes from 0 to a 2. How we doing? I'll show you one more thing. Remember on that router, we did show IPv6 interface, and it said I was only a member of the all IPv6 devices group. Look at what has changed. Now, it's still a member of the all IPv6 devices, but it says, hey, I'm also now a member of that all IPv6 routers group. That's all IPv6 devices. This is all IPv6 routers. Now, it added some other stuff here. It says, hey, by the way, I'm now sending out router advertisements. You know that advertisement you saw me send out up here? Advertising all that cool stuff about our network? By default, I'm going to send that every 200 seconds. Okay. And by the way, I'm letting the devices know to use stateless address auto configuration. What does that mean? That means I have my A flag set, which means I'm letting devices, hey, create your own IPv6 address, either randomly or EUI64. You don't need to ask a DHCP v6 server. Yes, Pamela.
Rick, what does ND space dad mean?
Where'd you see that?
It was
Right here?
Yeah.
Yeah. Okay, so good question. ND means they're a big Notre Dame fan. No, I'm kidding. Network neighbor discovery.
Neighbor discovery.
So this is part of ICMPv6. We're going to start getting into this next week.
Okay, thank you. And then the dad.
Dad. Okay. Do you want another joke, or no? You want the straight answer?
Okay.
Or no, it's okay. It means duplicate address detection is enabled. So good question. So what that means is this.
Thanks.
It means that devices typically will, so before this device created its own IPv6 address, and by the way, it's a global unicast address. This before it used, so the router has a link local address. Where is that? Where is that? There you are. I configured that. We configured a global unicast address. Okay. Our devices here have a link local address and a global unicast address. What duplicate address detection is this? It's an option. So what are the chances that this address is unique? What are the chances that, any of the addresses that we either statically configure, well, if it creates its own address, pretty good chance it's unique. But are we 100% sure? No. How can we be 100% sure? Well, what it does is sends out, remember an IPv4 and ARP request. It does something similar. It's called neighbor discovery. It basically sends out a packet before it says, before I'm going to use this, router does this, so let's stick with the host. Before it uses either of these addresses, it says, how can I guarantee it's unique? I know, I'm going to send out a packet to all IPv6 devices multicast. Hey, all IPv6 devices multicast. Means all IPv6 devices, which is everybody on our networks nowadays, going to pay attention to this. Whoever has this, let's stick with this link local first. Whoever has this link local address, this is this PC sending this out now. Whoever has this link local address, send me your MAC address. Now, what it's hoping is nobody's going to reply. Because if nobody replies, then it knows, hey, it's unique, so I can use it. That's duplicate address detection. It'll do the same thing for its global unicast address before it uses it. It puts it in something called tentative state. It says, before I use this, let me make sure it's unique. Does anybody else have this address? Or really what it says is, whoever has this IPv6 address, send me your MAC address. Again, hoping nobody replies. The router does the same thing. Before I use this link local address, before I use this global unicast address, I'm going to send a packet out. They send it out to the all IPv6 devices multicast group. That's the destination destination multicast address. It says, when I send this out, send it out to this group. If you're a member of this group, which you're an IPv6 device, check. Is this you? If this is you, send me your MAC address. But again, we're hoping they don't reply.
Thank you.
Yeah, good question. Let me just finish with this. This will lead us into the next group here. Let's see if I can do this real. Yeah. So, 1 second here. Too many windows open. Show this here. Just one little thing to show here. I can lower my windows here. Where? Okay, so if I'm sending something to FF0002 :1, all IPv6 devices. So this is the router sending its, let's go up here. Remember, it was sending the router advertisement to FF02 :1. Hey, all IPv6 devices, you need to know about this. And by the way, it's sending it from its link local address. So let's look. So its source address would be FE80 :1. Here's the source. Here's the destination. Okay. The destination is a multicast. It's coming from this source address. Now it's going to send it from its MAC address. What is this MAC address of this router? Okay. Well, let's actually do it here. I'm almost done here. Show IP, show interface gigabit 00. This is the MAC address of this router. So it's going to send it from its MAC address. Oh, that didn't work. Because I have to do this. Copy. Okay, that's the MAC address of this router. But it's going to send it to a destination multicast address, all IPv6 devices. The Ethernet MAC address for that is, well, let's take a look. I can't do it on there, but this is what it maps to. So anytime we send anything to all IPv6 devices, this is the MAC address it maps to. Okay. So what happens is your network interface card gets this and says, oh, this is an IPv6 multicast for all IPv6 devices. Yes, I'm going to accept this because I'm running IPv6. So remember, your NIC card is going to accept this. Remember, your NIC card's going to accept. I knew I was going to get myself in trouble with all this. Hopefully this makes sense. Your NIC card says, okay, I belong to this group here. Okay, all IPv6 devices. I had a better. Yeah, let me just leave it. So this is the net side. So I'm going to accept those destination MAC addresses. So that's how this destination multicast IP address is mapped to a similar destination multicast MAC address. So your NIC card will accept this. So when a device is enabled for IPv6, which your client operating systems are by default, the NIC card says, I'm going to accept anything for this multicast group. MAC address. And your operating system says, I'm gonna accept anything for a packet that's for this IPv6. All IPv6 devices multicast group. So both the NIC card and IP is accepting anything that belongs to the all IPv6 group, both at the Ethernet level, the NIC card level, and the IP level. They're mapped. Anytime a destination multicast address is sent to the all IPv6 multicast group, this is the Ethernet address it uses, the destination MAC address. And your NIC card will accept it because it's a member, because it's enabled for IPv6. We'll see that more in a moment, not in a moment, on Tuesday. But do you see that where I was talking earlier that there's a relationship, okay, between the destination multicast address in IP and the destination multicast MAC address in Ethernet? That's the correlation. There's an equivalency. How are we doing? I didn't mean to lose you in the last extra minutes. You're learning more about multicast if you're new to this than most people really understand. They're like kind of, all I know is I've got to image a bunch of computers. They belong to this multicast group, and I guess the application sends it to that multicast group. But this is what's happening, both at the IP level layer, IPv4 and IPv6, and at the Ethernet frame level layer. All right, I'll let you go.
Thank
Okay.
you.
Thank you. Have a
Thank you.
good day, everybody.
Have a great one.
All right,
Thank you.
thanks. Bye.
Recording stopped.
Yeah, John.
Quick question. So I was going through Canvas and I checked under check your understanding. It has the, looks like 9. There's 1, 2, 3. Oh, there's 4, 5, 6, 7, 8, 9, 10, and 11. So there's check your understanding quizzes, I guess,
They're old. I mean, for this class, right?
for this class.
Yeah. They're based on, some content I had previously. I just put them up there if anybody wants to look at some questions.
Okay, I saw the dates that it was
Done.
due, points
Done.
associated, and,
I just made them available.
okay. That was all.
Okay.
Thank you.
Have a good weekend, John. I'll see you Wednesday.
Yeah.